Let me introduce you to my Warco drill press. But could it be improved? Welcome back to the workshop. So in this video series we're upgrading your regular drill press, adding a load more features. So first off, we replaced the single phase motor with the 3-phase motor up on top, made all those mounting plates. Then we made a custom control box on the front here to control everything, and then we hooked it all up to this electrical cabinet. So in there we got our inverter that runs the 3-phase motor, there's a power supply that runs the logic relay system, and there's a safety over temperature relay in there as well. We also got the digital readout display mounted on the arm and the encoder mounted on the back of the machine. And in the last episode you saw me finish off this crank assembly, so we got the bevel gears mounted on here, so when we turn the crank handle we turn the ball screw and we can raise and lower the table. So next up we're going to make the big block that goes here, sits on the ball nut, and that connects onto the back of the XY mechanism to allow it to move up and down. So let's go over to the workbench, have a look at the material and the drawing, and let's work out how we're going to approach that. Okay, so this is a picture of the part we're going to make. So this is a ball nut bracket, so it connects between the ball nut and the part of the XY table. And the ball nut itself looks like this. This is a 16mm 5mm pitch ball nut, pretty standard item. So you've got your 6 mounting holes there, and then all the recirculating balls go around inside there. It's got this little retainer to stop them coming out. That mounts onto the screw, and then the little ball bearings allow it to just move up and down nice and smoothly. This is actually upside down, but effectively that will go into there through that big hole, and then it's bolted on at the 6 locations, and then when this moves up and down, it moves the bracket up and down, and this part goes onto the back of the table. So as you can see, it's not massively complicated, it's just quite big and bulky, and some of the challenges are I'm going to be using this 6mm 2-flute aluminium end mill, so it's got I think it's a 45 degree for aluminium. 15mm flute length, it's not that long, and then the overall length's 50. So there's going to be some challenges that will be sticking out the chuck quite a long way, or the collet, to enable me to get all the way down there, because we've got 23mm, so that's going to be somewhere up here. But I think we can just about do it. We'll just take our time, and then we'll machine that pocket out and run the cam operations on that. So in terms of stock, I bought this piece off eBay a while back. It's a solid billet of aluminium. It's about the same. It's pretty square. I think it's about 101 by 101 by, let's have a look, I think it's like 50, something like that. Yeah, give or take 50. So the first job's going to be just machining this down, just so we've got the blank size correct. And then once we've done that, we can go into the CNC part of the operations. So I think what I'm going to do is just rough this out with an adaptive first, a 3D adaptive, and that'll take most of it out, leave a millimetre, I think I'm actually going to leave 0.5 millimetre on the wall. And then we'll come down with a contour, and then when we get to this curve part, I'll do that in, well, I've got 2 cam operations that I've programmed in. One is I think about 0.2mm, and we'll just come down in small steps, and it will just leave a kind of very faint staircase type effect on that. So because obviously this is just a regular end mill, it's not a ball nose one. We'll come back to that in a minute. So it'll take that down, and then I've got another cycle which is 0.1mm, which will take a bit longer. So the idea is we'll run the 0.2, see what it looks like. I mean, it's only a cosmetic finish, it's just to make it look nice around the corner rather than leave a sharp edge. And we'll see what that looks like. I might just hand finish that, or I can run the 0.1mm. So we'll have a look at that when we get to it. And then there's just a horizontal surface operation here, and then we'll come in and just take a pocket here about 10mm deep. There's no way I can bore that through there with obviously this end mill, not a chance. So we'll take that through, leave about 2mm on the wall, because then what we'll do, well, once we've spotted these 6 holes, sorry, we'll then put it on the 4-jaw chuck, hold it, centralise it using the dial test indicator, and pick up off that diameter there, which obviously it's got stock to still take out, but just pick that up, centralise that, and then we'll use the lathe just to bore it all out to the final size. Then once we've done that, all we'll do is then open these holes out to the final size. I'll probably just use a cordless drill because these larger diameter drills, that spindle doesn't do very well with those. It tends to bog down. It's really a high speed spindle for small stuff. So I'll just finish those by hand and then tap those, and that will be it. So I think the big part of this operation is going to be just getting that down to the final stock size. So let's go and put it in the vise and start machining it down. So I've got it clamped in the vise. Luckily I had just about enough travel. Now somebody's kindly dropped this on the corner, so we'll use that as the piece we're going to chop out. There's two ways you can do this. So one is that as you're squaring it, you're also bringing it to size. But the way I prefer to do it is to bring it, so take the minimum off, bring it to a square size, measure where you've got to, and then with a perfectly square block, bring it into dimensions, sort of split it into two stages. So I find that a little bit easier to do. So this is going to take a little while. Let's get started. Well, that wasn't a good start, was it? I don't think the depth cut was that much. Maybe it was a bit high feed rate. Luckily I've got another 5. Back in a minute. Right, what happened was I didn't tighten the collet. So as it went into the work, it just pulled the end mill down, and that's why it engaged so much. I thought I didn't put that much depth of cut on. Right, let's get another end mill in and tighten it up. Back in a minute. I'm only skimming over it quickly, but it's not too bad a surface finish, considering we've only got a tiny end mill. Okay, let's take it out and see how square we are. Okay, looks good. Okay, across these sides. One, two, three, and 4. Okay, we'll call that good. So obviously it's not to the final size, but at least it's squared up, and that piece, yeah, where the end mill pulled out the collet, because I hadn't tightened it up, we'll make sure that that's part of the scrap. So I think we'll date them off here. mark it up. In fact, I think what we'll do is just pop it in the vise, remove that, we'll bring it down to final thickness, so if that surface feels alright, so that'll be our datum. We'll bring it down to I think 40mm, and then we'll start marking it out. Okay, then eventually we get down to our final stock size, so we'll take it out, check we've got the right dimensions, then we'll mark it up, ready for the cam operations. Alright, let's go and check the measurements. So we should have 40mm wide. Yeah, okay, it's fine. 63 wide. Okay, that's just touching there. And 94 long. Somewhere there, I think, just square. Yeah, okay, brilliant. We're down to our final sizes, so just so we're going to CNC the last parts here, but just so we know where we're going and make sure I'm not going to make any errors, I'll just mark it up anyway, at least with these two lines with the Sharpie. And then we'll start the cam operations. Okay, so here's our 40mm line. Okay, and the one here is 35. Just from there. Okay, obviously that'll have a radius on it. Now we need just need to chop this out. Right, see you at the CNC machine. Okay, so before we go too much further, machine a lot of the block away. Now we've got quite a lot to hang on to. We'll do these two 45-degree chamfers down here, and then we can get on with the main machining. So just to check, I've just got it set up against this block here that's pretty close to 45. So okay, we'll just make sure it's 0 on there. Now this is not super accurate. I don't have a sign bar, but it's only a cosmetic feature, so hopefully this will be good enough. There we go. 40 depends on the exact position. 45, 45.1. Right, let's go for it. Got the part up on these shallow parallels just to give me a little bit of height off the jaws, and then we've touched the tool off on here, zeroed it there, zeroed on the back and zeroed on the top. Now we've got quite a lot of hours in this part, so before we run the cam cycle, what I'm going to do, I'm just going to put x equals 200 at this point, and then move the machine over to the new x0 over there, and then we'll run what's called an air cut. So we'll run the G code in mid-air, just have a look and see what it tries to do and make sure it's doing what we expect, and then we'll bring it back. So in our DRO we're going to type x equals, let's say 200. Okay, so now it thinks the part's actually over here, so we'll move it back to 0. Sorry about there. So we've just got to remember we've put that offset in, so it should start machining over here. The other thing you'll notice is I've got a lot of stick out in the end mill because we've got to reach down a long way. So we're just going to do it in stages and see how we go on. So it should be okay. It might rub ever so slightly at the top here, but not much we can do. We've only got an ER11 with a 6mm end mill, and that's about as long as you usually find. Right, let's run our air cut. Okay, we'll hit cycle start and see what it does. Okay, we won't run it right to the end. That looks like it's going to behave itself. So let's set it back and cut the part. Okay, it took an awful lot longer than expected just to machine everything down to the right size and then drill out these holes in the pocket around the back and all the sort of 3D adaptive stuff around here. But we're there now, so we just need to tap out these holes and then we'll go over to the lathe and drill the centre part. So I spot drilled these on the CNC machine 3mm. Then I'll just open them out to 4.2, which is the pilot for a coarse M5. Now I have just started these using the drill and then just using this little guide and just getting them started so they're square. And now I'm just hand tapping them. I prefer to do it that way just in case, well, it tries to avoid breaking a tap. You've got a bit more feel if you do it manually. With holes like this, I prefer to tap them pretty deep because you never know quite what size screws you've got. Oh dear, got on hand. Another reason for doing it manually, you can stop straight away. Yeah, you never know what length you've got, and it's annoying to bottom out and then you could crop them to length, or you'll come back in and set it all up again. So plenty of thread on them. Right, I'll finish these out and then I'll see you on the lathe. Okay, it's a little bit awkward to set up, but we finally got it set in the 4-jaw. So we CNC machined that bore with a little bit of stock to remove there, just to give us some guidance. And we just about got it zeroed and dialed in. About 0.01 or something, bit of fluctuation. But that's okay, it's just a clearance hole for the ball nut to go down. Yeah, pretty pleased with that. Okay, so we've got to be a little bit careful here because there's two things. One, we've got this, well, three things I guess really. It's going to be a little bit out of balance, so we might have to run a little bit slower. This is sticking out a long way, so when we bring the tool post in for the boring, we've just got to watch how far we can go. So we'll have to stick the boring bar out quite a long way, but that's what we've got to do. We need to make sure when we come through the back, we don't hit the back of the chuck here. And then the third thing is, because we're hanging a long way below here, when we bring this carriage along, we just got to watch out we don't hit this part of the this saddle here when this is swinging round. So we'll check all those clearances and then just set the whole thing up so we know when it's spinning, we're good to go, we're not going to have any clashes. Right, so I think the first thing is we'll just put our centre in there and we'll gently drill out our hole, because we're holding it back here and we're trying to drill and do some operations on the material kind of out here, and I mean it's unlikely, but I just don't want it to grab and suddenly flick out there because we're just kind of hanging on the back of it here. So we'll take it easy and we'll get it done. As you can see, I've got my boring bar sticking out a long way there, and we needed to make sure we've got clearance here as we go through these little screws that hold the gib in place on the top slide. So we've got clearance there, clearance at the bottom there, and then I can just about see in there. That bore comes out right next to the edge of that step on that jaw, so there's a little bit of relief, and then there's the step. So I'm just going to stop it just short, and then I'll just hand finish it when it comes off. And we've currently got that set to about 0 is when the tool, I'll just stick it out, there it is. And the bore is basically, the boring bar's just got to the bottom there, so we'll take it out and go to 0. That makes sure we don't machine into the jaw. Very, very close. Right, so the last twist drill I put through there was 25mm, so we'll just open it out to 28.1. The ball nut's 28, and that just gives us a little bit of float and adjustment when we put the whole thing together. Right, let's get boring. Right, just deburr that edge and then we'll see if the ball nut fits. Okay, here we go. Should be a little bit of wiggle room for adjustment. There we go. Perfect. Okay, and there's the ball completed. So we'll take it out of here, just clean up all the edges, deburr it, give it a bit of a clean, and we'll see you over at the bench. So when it was in the 4-jaw, one of the jaws was holding here, and it was sort of lapped around there, so I couldn't drill all the way through. So I don't know if you can see that, but there's like just a lip of material just remaining. So we'll just use the step drill to take that out, and then the snail countersink just to bring it, or just to take off the last bit. Nearly. See if we can get the last bit off with this. And here it is finished up. So I've got all the holes tapped for the ball nut there and the ones that go onto the table. Now you'll notice I've also got them marked out on the bottom because originally I was going to put the ball nut on the bottom so all the forces were pressing down onto that flange. But I realised it would have made it very awkward to kind of reaching round underneath to get to the back of these screws to put it in. So I've marked it out both sides to give me the option, and I think actually I've decided I'm going to put the ball nut on the top like that. And then I can just reach through the slot and have easy access to these. It does mean it's pulling down on those threads, but I don't think that's going to matter. Right, so next we need to get this mounted onto the ball screw. Actually, before we fit it, we'll just strip it down. We'll take all the balls out, we'll take these end retainers out and the little guide tracks there, give it a good clean and then rebuild it. But before we start that, I've just had a delivery of this coffee and walnut cake. So, see you in a minute. Very nice. Right, so let's get this done. So we'll take the plastic sleeve out that stops the balls falling out. That's pretty clean. Doesn't look too bad in there actually. Nope. Right. Take these end pieces off, it will help. You might be able to see. Yeah, there's quite a lot of dirt on those little orange guide tracks there. Yeah, we'll strip it down and give it a clean. Okay, now it's empty, that's what we got. Actually, that's not too bad. I've seen a lot worse. Yeah, it doesn't actually look too bad. I'll give it a clean round anyway. It's actually got some grease in it. Let's see what we find. Yeah, maybe not so clean. For an application like this, it's not going to get a huge amount of use. It's not like it's on a CNC machine where it's doing lots of rapids. Probably would have been fine without cleaning it at all, but at least I know it is clean and I haven't got any grinding dust in there. Looks like lithium grease. Call that good. Alright, let's rebuild it. Oh, here we'll just measure the diameter of those balls in there. So they're normally around 3mm, but they're actually 1/8 of an inch, so 3.2 or thereabouts, or 3.18 perhaps. And then they have a tuning range just to get them best fit on any given ball screw. I was hoping I don't drop it onto the floor because we'll never see it again. Luckily it keeps rolling down there and into the pot. There we go. So 3.15. And it's nearly 1/8 of an inch, just a little bit under. Should be 0.125, wouldn't it? So they vary slightly from around the 3.18mm or 1/8 of an inch, just to give them the exact tuning they want onto any given ball screw. So they are tailored, so usually you can't mix and match these. If you put this on another ball screw, it'll probably be a little bit baggy or a bit tight, so just watch that. You can't usually mix and match. Let's just pick another one at random. I'm guessing they've all come out the same batch and they're all going to be about the same. Yeah, about the same, aren't they? Right, let's rebuild it. Right, first thing to do is just put these little guides back in. And that's the last guide in. Yeah, right. So the trick to get the balls back in is we're just using this grease. I think this is a lithium grease. I've had it a long time. And you just get a little dab. There we go. A little dab on the end of your tool. You can use a wooden toothpick or something. This long screwdriver I think works for me. And we grab one. And we put it in here. I'm going to try and load it from the back, which is down there. Okay, we're about halfway through now and you can see it's starting to fill up. Right, keep going. That's a bit better idea. It's important when you do this, always hold it over the bowl, because if it goes, or your little box, if it goes onto the workshop floor, you'll probably never see it again. And the last one. And we'll see if I've done it right. Yeah, it should go in there. I think we got it. So you'll notice it doesn't fill right to the front here. So although these little grooves are machined all to the front, you don't have any balls right at the front here because this little guide then sends it onto the return to go back the other way, and the same when we go this side. There you can just see. They don't go all the way to the rear because they go onto the return guide to go back round again. Okay, done. Right, we'll just put the retainer on the front and then it can go onto the ball screw. Now, rather than disassemble this, because I've got it set just right so it gets a good engagement, we'll just leave it there and then we'll just see when it's installed if we can get the ball nut onto there. And we got our trace just in case any fall out, because this doesn't always go smoothly. Should. Sometimes they can bind up and just jam a bit until they're finally seated properly. Right. Here we go. So early because the thread's probably at a different location, so we need to let that spin. Back that off a bit. Yeah, I normally put this in last, but for some reason I'll put it in first. Here we go. Right, that should allow it to line up now. There we go, that's it. I think we're there. We are. So at this point you hope you haven't put it on upside down. There we go. Yeah, feels good. Right, now which way around do we want it? Grease fitting there. I think we're going to have to access it from the rear because if it's there, with the plate on the front I won't be able to get to it because it'll be in the corner, so we'll put it that way. In fact, let's fit that now. There should be some in here. This is a box where, or one of the boxes that I collect lots of different bits and pieces. I think that's the same. Let's try that. Oh no, here we go. Okay. I'll put a little dust cap on it. There we go. And then a little bracket, I'll say little, it's quite big. I'm not going to get to that either. I thought it was going to be over here. Put it like that. Always the little things, isn't it? I definitely can't get to that. And might be able to get to that through the gap here. Alright, we'll put it that way around. These are M5 cap heads. Nip it up for now. It's not quite in its final position. Okay, there we go. Alright, let's give it a test run. So obviously this will just spin round, so I'll hold it. Great, yeah, it works. I was a bit worried about how long it's going to take to move up and down, but right, let's time it. Start the clock now. Bearing in mind, I don't think I'll take it right from the top, so it'll probably be too close to the chuck. Takes that long. Very happy. Nice. Well, that's it for this video. It took an awful lot longer than I was expecting to machine this block, but we're there now and it works, which is the main thing. Very pleased with it. I've had quite a few people comment that they're quite interested in modifying their own drill press, so they were having a look at my videos just to get some ideas, which is great. It's inspiring people. If you're interested in these particular items, so the DRO, the switch gear that's on there, sort of start-stop switches and so on. There's the inverter that's in the electrical cabinet over there, the ball screw, these linear scales that go along with the digital readout, and these Machifit 20mm linear rails that are going to go on the front of the machine. If you're interested in any of those, there's links down in the description below. Now, a couple of those items, because it's taken me so long to get this far, a couple of those items are discontinued, I think some of the switch gear, so I'll just put the closest alternative, and then you can go and have a look and see if there's anything there that takes your fancy. Now, the other thing that's worth noting is that Banggood are having a sale that starts around the 25th of March, I think it runs to the 28th, and they've also got some coupons and some money off vouchers, so that might be a chance to pick up something even cheaper. Next time I think we'll have a look at the plate that goes on the front here. So this is the stock for it, 6mm aluminium plate. So that'll go on the front there. It's got to obviously be machined to size, and then there'll be a slot down there for that ballnut bracket to come through, and then there'll be two of these linear rails. These are the Machifit rails on the front there, and I think we've got 6 carriages on there, so 4 for the knee system and then 2 that are the guide system for the quill. And then the other thing this plate will have on it is some grub screws here to level it, because the box section's not super level. So it can bring it all into plane and get it aligned with the axis of the drill. So stay tuned for the next episode. I think we'll be doing that next. So as always, thank you for watching, and we'll see you next time.